All right. Let's see. I don't even have my watch on. Hold on a second. I got to look at my camera. Let's see. My phone here. It is what's today? Today is the 16th, right? Today is Wednesday.
Yes.
Wednesday the 16th of October 2024. Pete, what number is this?
Number 253. Crank it in, Robert. Crank it in, Ralph.
Here we are, guys. It's been a while. I have changed countries. I'm back in the United States, and it's time to do another Solder Smoke podcast. But first, we want to mention we have a sponsor. We rarely have a sponsor, but we have a sponsor now, and it's our friend Carlos in Chicago with Parts Candy. Carlos makes some really cool test leads. I think Dean has some, Pete has some, I have some, and Parts Candy is back. He's doing standard test leads. He's doing hook clips and alligator clips in 12 and 32-inch leads and multimeter leads. So just check out Parts Candy. I have the symbol for Parts Candy on the Solder Smoke blog. Just click on that. It'll take you there. Parts Candy is the place to go. And here's the phrase that I developed. I get credit for this phrase. Don't scrimp with a crimp.
Yes.
There you go.
Good
Carlos
stuff.
liked that one. All right.
You're a poet, Bill. You're a poet.
I have a knack. I have the knack for this kind of stuff. I have a way with words, you know. All right. So we're going to start with a little travel log. First of all, I mentioned that I've changed countries. I'm back. Obviously, for those who can see the video, I'm back in the northern shack, northern Solder Smoke, East Coast headquarters. But we made a quick trip up to New York City. Elisa and I were up in the Big Apple for a few days, and a lot of people don't like New York City. I do. I like it, and so does Elisa. Elisa really likes it too. And we were in a nice neighborhood. We were up in the Upper East Side. I didn't get a chance to see Dave Bamford, W2DAB, and I felt bad about that. But we were busy, so we're going to go up again. Maybe we'll see him when we're up there again. But one thing I want to note, we were in the area. Elisa likes the a park that they've created in New York called the High Line. They were going to tear down an elevated subway line on the west side of Manhattan Island, but cooler heads prevailed, and they decided to leave the elevated platform there and turn it into a very long, very narrow park with a lot of plants along the way. It's become one of New York City's big tourist attractions.
The
So we spent a lot
skyline,
of
right?
It's the High Line. It's
High
really,
Line,
really
right.
nice. Yeah, High Line, really nice. And we've gone there several times. This time Elisa managed to run into the designer of the park, Pete Olaf.
Oh my gosh.
And so we took selfies. She was like really blown away because he's one of the major figures in garden design, landscape design. So that was really kind of cool. But the other thing was cool, we took the Acela train up and got off at Penn Station, and they've constructed a pathway out to the High Line, which is really cool. But you're on 34th Street, so you're in the area around the Empire State Building. This one thing I want to note: how long did it take to build the Empire State Building? I was blown away by this. They started construction in March 1930, in the depths of the Depression. They finished construction of the building in April 1931.
Oh wow.
Wow.
One year. There was one 10-day period where they built 14 stories.
Ooh.
I mean, can you imagine? I mean, we have trouble getting one single family home built here in a year. They did the Empire State Building using 1930s technology. They had 500 trucks arriving every day. 500 trucks. Pete, I know this will be of interest to you as a kind of an industrial designer or a supervisor of big projects. 500 trucks. They had to build a rail line into the work site. They had more than 2,000 workers every day building this thing. And they managed to do it in just about a year, which is pretty amazing. Anyway, that's my plug for New York City. Dean, you were out in the Bay Area.
I was for our second grandchild, a granddaughter, our younger son and daughter-in-law had a baby. In fact, just after the last podcast, I jetted out to the West Coast to be a grandpa for a couple of weeks and had a wonderful time out there.
Well, congratulations. Good to get out to the West Coast. Hey, one thing I wanted to mention, as long as we're in the intro travelogue section, I did a movie review on a film that we've been hearing about, and somebody from the Solder Smoke community alerted me to this. It's called The Conversation. It's an early film by Francis Ford Coppola. I think before he did The Godfather, before he became famous for Apocalypse Now, he did a movie called The Conversation, which was set in San Francisco in the Bay Area, and it's about a guy named Harry Call. He's a fictional character, but he's an expert on detection, on bugging, on picking up conversations that people don't want him to hear. So you get a lot of scenes in the movie where they're into people's like shacks, people, repair shops. And I started thinking, holy cow, Harry Call, he clearly has the knack. He must be based on a real world person. And sure enough, he's based on, I think, on Marty Klein, W3VCG. And Marty and of course the fictional character Harry Call clearly have the knack. So I have a link to the Solder Smoke movie review on the page. You'll check it out. Finally, we spotted a paisan of Pete's.
Joe Piscopo.
Joe Piscopo. The other day, we've been looking at these old Bell System videos because there's some great videos there. And I'm looking through like the catalog of videos, and something catches my eye, and I say, wait a second, I know that guy. And I zero in on it. It's Joe Piscopo. And I checked, I was able to confirm it looked so much like him.
Younger.
A younger Joe Piscopo. Joe Piscopo around the time that he joined Saturday Night Live, which was a long time ago. But there he was. So I have a video of that, and I have a link to that up on the blog page. But guys, if you don't mind, I'll start with Bill's Bench here, since I got a lot of stuff. All right. First, I want to file a report from Solder Smoke Shack South. First, I want to just note, when you're at Solder Smoke Shack South, you're definitely in the tropics. And what we mean by the tropics is you're somewhere between the Tropic of Capricorn and the Tropic of Cancer. Tropic of Cancer is the northernmost point. It's a line that goes around the globe. It is the line in which sometime during the year you will get vertical sun rays. Okay. Now, I found out that where we are in the Dominican Republic, which is about 18.5 degrees north, you get the vertical sun rays on July 31st at around 12:30 noon. So Lisa and I happened to be going into a supermarket parking lot at precisely that moment. I looked at my watch. I said, this is it. Let's go. So we get out, and I stand there. I got a picture of it, I think, on the blog. And I take a picture. I have Elisa take a picture of my shadow, the shadow cast by my body and my baseball cap. And it is indeed vertical, it's straight down. So that happens on July 31st in the Dominican Republic. One thing I discovered, that dogs have an instinct about why it's not a good idea to go out at this hour. Guapo, the dog, would refuse to go for a walk. He would growl at me if I suggested, let's go take a walk, Guapo. He'd like, man, mad dogs and Englishmen go out in the noonday sun, but Guapo is not going for it. So he wouldn't go out. But that was kind of fun. But it's starting to get cooler down there now. We're still in hurricane season. There's a hurricane kind of that could be approaching right now. It's a tropical storm. It could turn into a tropical storm. They're going to name it Nadine, but it looks like it's going to go north of the island. So anyway, we're prepared. We have hurricane prevention measures that we've taken. We've got some metal storm curtains plugged in and built into the apartment, so it should be okay. People have been asking about astronomy down there because we have this great top floor terraza or terrace. And it's not been great because during the summer months you get a lot of high humidity, so there's not a lot of good viewing for astronomy. But we have been seeing a lot of satellites and a lot of meteors. For antennas, I haven't put any antennas up on the roof yet, but I've been fooling around with a quarter wave vertical, actually a series of quarter wave verticals on a fishing pole. I have a fishing pole, one of these telescoping fishing poles that go out to about 16 feet. And it makes it really easy to put up an antenna very, very quickly up on the roof. And I've worked a lot of DX with that. Obviously, a concern for antennas when you're up that high in the tropics is lightning suppression. So I've been waiting for them to put up a lightning suppression system on the building. I think it's going to be happening soon. But when I put up an antenna, it's not enough just to ground half of it. I got to put the lightning suppressors in there. And I ordered a couple from Amazon. They came in, and it's really interesting to see how they work. The IMSI guy actually has a good video on how lightning suppressors actually work. Because if you ground a dipole, you're only grounding half of it. You're not grounding the other half of it. The other half of it goes through all your rigs, the radio, the building, everything else. But when you put the lightning suppressor in there, it's got a little tube in there, an argon gas suppression tube that will conduct if the voltage on that line goes beyond 250 volts, which of course a lightning strike would be way beyond 250 volts, and it shorts it to ground. So it limits the amount of damage. I don't think it's going to save you from a direct hit with a lightning strike, but it'll prevent most of the strike from going through the house. At least at 250 volts, it'll short over to ground, and hopefully that'll help prevent a lot of serious damage. We're thinking about putting up some solar panels up on the roof. We have space for about 12 panels. People have been talking to us about a 5 kilowatt system, possibly with or without batteries. And I ask the readers who know about solar panels to send me some suggestions. See what you think. If this would be a good idea. We got a golf cart. Golf cart's pretty cool. Drive around a golf cart. Golf cart's fun. And talk about electrical powers. Electrical golf cart. We got that. I got a new PC down there. Last time we only had my my Chromebook, which was woefully inadequate, I discovered. But thanks to some suggestions from the Vienna Wireless Society, I found out that they're selling these tiny little PCs. They're the size of the palm of your hand, but they're a Windows 11 PC, and it's called the Beelink. They're very tiny. I picked up a 24-inch screen to go with it. It's working really well. I've got a link to it up on the blog, but it's got a lot of RAM. It's got a lot of memory and things that I could do with it I could never do with the Chromebook. So
the Beelink clips right to the back of the monitor, right?
Well, I somehow couldn't get it on there. It wouldn't go on very well, so I just put it in the shelf down below. But you could put it right on the back of the monitor. It's really pretty cool. And then finally, I have been doing a little bit of kind of solder melting down there in the southern shack. I brought with me a version of the 1510 rig, and man, right in the middle of using it, I started noticing a flaky connection. Something was wrong. Sometimes it would work, sometimes it wouldn't work, and I suspected that my Ramsey kit amplifier was at fault. A Ramsey kit amplifier that's taking you back. But it turned out that was not the culprit. I got to use my new scope, and I found a loose connection in the 1510 transceiver using the Regal scope that I have down there. So it was very, very satisfying to get the whole thing going and to use the scope to do it. It was a fun fix. I intend on building a second 0.1 kW amplifier, a second one. So the question is, which one should I build? Should I build the EB63A again, because they're still available from Communications Concepts Incorporated? Or should I build another amp? One of the shortcomings of the CCI amp is it's got fixed bias. And Dean and I have been fretting about IMD, which we'll talk about in a few minutes. But the other amps that CCI offers allows you to adjust the bias, and you can move things closer to actual Class A. Whereas with the CCI EB63A, you're pretty much stuck at Class AB, which is sort of a intermediate level there. But anyway, we'll talk about that in a minute.
There's a ton of these kits available too that I wonder about. You see them on eBay and Amazon, and they've got, they advertise 100 watts. They're a little board that's maybe 4 inches by 6 inches. It's hard to tell what the transistors are. Pete, have you looked at any of those?
Yes. And the problem is most of them are using something like an IR of 510, and after 20 meters, they drop off the face of the earth. So they're rated at 100 watts at 14 megahertz. And beyond that, you're lucky to get 20, 30 watts. Bill, you need to look at the AN762 by CCI. and it comes in two versions. One version will get you 140 watts, and another version will get you 180. And it's just depending what device you put in there, and there's about a $20-$30 difference between the two. So you can move that up to almost 0.2 kilowatts.
Wow.
and it's a good quality. I've had the AN762 probably for 20 years now, and I put in. It was my fault. I smoked the finals, but that thing is just a real workhorse. So take a look at the AN762. And now the EB63, I think has the relay built into it. Does it have?
Yeah, it's like an RF sensor. I never use it.
Okay, well, the 762 does not, but I had that, and I can tell you, it's a real workhorse. And when it says it'll put out 140 watts, it'll put out 140 watts, 10 meters.
All right, so there you go. That's the kind of advice I was looking for. Thank you, Pete. I will check it out because I do sort of want to move beyond the EB63A. It's been nice, but I want to have a little bit more flexibility. I think that would do it. Finally, the only thing I want to report from my bench, and this is the northern bench up here, is that I spotted VE7SL Steve put a nice blog post about his efforts to monitor what's called digital selective calling, DSC. He talks about how in the old days you used to get on the maritime bands and monitor the CW transmissions from ships at sea and from shore stations. And it was great fun because you'd start to recognize the different CW characteristics, the different fists of the different operators. I never did this as a kid, but I could have. But he says he thought that these kind of thrills were long gone. CW is, of course, long gone. But this same system of ships at sea reporting to shore stations is continuing in the digital realm. And they're using a system called digital selective calling, or DSC. And it's basically a tone-based system where somebody who wants to call a specific ship can put the tones in, and boom, that ship gets the call if they're in range of the radio. So the ships are constantly out there trying to establish which shore stations they could contact. It's only going to be used in the event of an emergency on board, but most of the signals being transmitted are for tests. And the software that you use to decode it is amazingly simple. I downloaded the software in about 1 minute, and I got it operating in about 3 minutes. And then I didn't even have to do an interface with the computer. I just held the microphone up to the audio output of the receiver. I needed a receiver. I needed a general coverage receiver, and Farhan's UBitX, MicroBitX, came to the rescue because I remembered that he deliberately put a general coverage receiver in there. So I was able to tune to the specific frequencies that they were using, and all of a sudden, boom, these digital signals started pouring in from around the world. I was getting the Shanghai shore station. That was cool. Hawaii shore station, Australia, New Zealand, Miami, Bermuda, all over the world. Really great stuff. You know, it was, I put in the blog post, it was like cheap nerd thrills. It was easy to do, but it's a kind of thing. It sort of reminded me of what I did with the dry ice and the Wilson cloud detector. You do it for a day or so, that's it, done, boom, disconnected, put the whole thing back on the shelf. But it was good to do just one day. I mean, people have become completely addicted to this kind of thing. But you know, there's always somebody who wants to harsh your mellow. Always somebody out there who wants to harsh your mellow. It's like the guy who said we should be busted because of what we did in San Francisco on April 1st. I put this thing up, this really I thought kind of joyful post about how much fun it was to listen to the DSC stations. I get one comment, only one comment comes through. And I think, wow, somebody comment. Guy writes, "It is illegal to monitor or copy or transcribe, you know, private communication." Boom, illegal. No, it's not. No, it's not. And so I went back and I just said, hey, could you provide a link or a URL or a reference or something showing that what we're doing is illegal? No, nothing, no response. But my mellow was harsh there for a few minutes, just for a few minutes. Anyway, that's what I've been up to. Before we move on, Pete, what time is it? What should we be doing at this point?
Shameless commerce.
All right, this is a kind of a painful shameless commerce division, but it's something that needs to be said. We've been discussing this, and I will just start out by saying that people should realize that our podcast and associated blogs are kind of in danger. And they're in danger because we have been noticing that the number of people visiting the blogs and listening to the podcasts dropping off pretty considerably. For a while, I was blaming Google. Oh, it was very satisfying to blame Google. Google's at fault. Monstrous Google. Google doing bad things to our podcast. But I found out that's not really true because I managed to get some stats that showed the number of people that were coming to the podcast through Google, and they're pretty much flat all along. It's the same amount of people, so it's not Google. It may be a couple of things. It may be that there's a lot more competition out there right now. People just have a lot more to look at. Also, it may be that the number of people that are really interested in doing the kind of home brewing that we do is really not that big, and they have other things to look at. But for whatever reason, the readership and listenership is declining, and it is having an impact on our morale. Let's say that Pete has already gone into permanent hiatus on his blog, which I think is a real loss for the ham radio community. And something similar could happen here on the Solder Smoke podcast. So what are we asking for? What can we do to this? We don't really want to do this. So please, I would say on your blogs, on your pages, on things that you are working on, please put links up to the Solder Smoke blog, the Solder Smoke podcast, Dean's website, and whatever. I hope Pete stays up for a while, but put links to his so that people will know where to go to read it. Talk up the blogs and podcasts on your own blogs and on social media. One of the suggestions we get back is, oh, you need to do a lot more marketing. We're just not into marketing, all right? I mean, if people don't really want to visit the blog or don't want to see the podcast, well, they don't want to, all right? So fine. Maybe it means that we shouldn't do it. I hope it doesn't come to that. The podcast has been pretty much active for about 18 years now. I think it's been a long time, and I think it would be a shame if we just discontinued it suddenly. But look, if I think Dean pointed out that any YouTube star or Instagram notable or influencer gets like millions of views, whatever they do, and we're lucky if we get hundreds of views for whatever we do. So it's all kind of pocket change. We never really minded if it was a small amount of listeners, I think. But when it starts getting down below 100, then you start wondering, why are we doing this? I mean, if nobody's listening to this thing, I mean, maybe we should not be doing it anyway. What do you guys think?
I think we like talking about radio. Bill, you and I talk on the phone for an hour, often days. I just like talking about radio, and I don't mind recording it and put it out there. And again, as you say, if people come, they come. If they don't, they don't. As long as we don't turn it into a job, right?
That's right.
So yeah. I mean, Eric in the QSO Today podcast, he does a great job. But he sent you that 2-page list of marketing ideas, and our first response was, "Oh, that's work."
That's work, and we're retired, man. I don't know, Pete. What do you think? Any thoughts on all this?
Well, yeah, that's what led me to the decision to stop writing the blog. Was first off, this year I tried real hard not to make the blogs continuous. In other words, you have this project, you keep talking about it. So every day I try to come up with a different subject, and that really taxes you so you don't repeat yourself. And you get 50 people look at it, and I'm spending a lot of time, and I don't have much time putting that together. And I'm saying, why? And just it's indicative that people are not into homebrewing. There's a group of us who are very dedicated to it, but there's many more who are not. And I guess the thing that really got to me was some guy with a forecall bought this Chinese radio, and he puts out this YouTube video about unboxing the radio. So he shows the box. It came in a wrapper, and he unwrapped it, and he says, well, here's all the parts. And he says, okay, I'm going to plug it in. He plugged it in, and he says, there's the radio. Thank you. In one day, he got 22,000 views. I mean, there was nothing technical about, hey, this really works. It's great. You know, it has good IMD, you know, or no spillover on channels, works in all bands, puts out 5 watts from 80 through 10 meters. Just, he plugged it on and made a contact, and that's it. 22,000 views in one day. And I'm saying, that's what people want. They just want to see how to unbox a radio, and they're not interested in what the nuts and bolts and how's this thing work and what are performance improvements. So I said, I'm done.
I think that you got a real good point there, because Dean and I have been talking about this also. I mentioned that there's a lot of competition for views. Frankly, a lot of the people that are competition for us, none of them are actually building radios the way we do, right? But when you look at the number of views that their videos get, or other things, you do see counts up to 22,000. And when you realize, okay, we build the radios, we talk about how we build the radios, and we never get close to 22,000. So it's an indication that people might not like this style of construction. People might be more interested in the plug and play kind of thing. Like, I got this thing, I opened the box, I plugged it in, and there you go. So I don't know, but then there is a little bit there on the other side. My son was here this weekend, and he was taking a look at the stats for the Solder Smoke blog, and he noticed something that a number of others have noticed, and that is that we had a really big blip in readership around the beginning of the year. And he said, well, what were you doing in that period in the beginning of the year? And I had to think about it for a second, and I realized that was the time that Dean and I were working on the Thomas Jefferson DC receiver project, and we were doing a lot of posts and a lot of sort of how-to kind of stuff, and that seemed to attract, I mean, not 22,000 levels, not Ariana Grande levels of viewership or readership, but more to the level that we were accustomed to. So I don't know. It may be a combination of factors that are involved in here, but we're asking folks to don't let the podcast and the blog kind of slip away. But if people don't want to watch it, if people are not interested, then you know, we'll have to reevaluate at some point. But anyway,
I have 2 data points for you. I have getting close to 300 YouTube videos. 300. And the highest I ever got was 32,000 views on one single video, and it has absolutely nothing to do with amateur radio. It was how to stop water intrusion into my Jeep Wrangler. I came cover over the vent. It lets the air come in, but prevents the water, because the water was coming right in through the vent, right in on your socks. 32,000 views, and I'm saying, okay, there's something that caught somebody's interest, but it has nothing to do with the radio. And the second one that I did here was kind of tongue-in-cheek. I put up a video about a radio I was trying to build, and it just was crap. So I took a video. I said, here's a crappy radio. Really crap. Listen to this. This doesn't work. It's got all these things. Here's all the problems with it. One day, 2 days, 2,000 views.
Yeah, I know. I had a similar experience. I did one several years ago. I think my one of my leading videos or podcast or blog post was I had spotted a radio in an old TV show, and the old TV show was like That 70s Show. So the line for the blog article was That 70s Show. People went nuts. Everybody wanted to see what was on about That 70s Show. They didn't care about the radio stuff at all. So anyway,
hey, Bill, I know what people don't want to hear about. 3 old guys complaining about nobody listening to them.
I know. Our viewership and readership is plunging right now. They don't listen to us. They don't like the radios that we build. We're doomed. Full retirement beckons. Hey, but before we sign off purposely, we got to do another plug for our friend Carlos at Parts Candy. We're here now, and don't scrimp with the crimp. Dean has them. I have them in 2 different countries. I have them in 2 different countries. I have some of them here. I got some of them in the Dominican Republic. Another thing we wanted to talk about. Look at this, gentlemen. Hold on. I hope you guys have received this. Pete got one. I got one too.
I didn't get it yet.
Look at the size of that thing. It's a ginormous Sprat.
Wow.
Usually Sprat is much smaller. This is the Sprat Special 50th Anniversary Edition. 50 years of the GQRP Club and remembering George Dobbs G3RJV. So, I mean, they put out this special edition. It's really beautiful. I got it. Look at that. The back cover there. There's George, the current president of GQRP. I mean, just a beautiful thing. And if you can order yours, and I will put up a link to the blog, but if you guys just want to look for the GQRP Club online, there'll be places where you can order them and you can get yours. And also, we always say, if you're not getting Sprat, Pete, what is it?
You're wrong.
You're just wrong. You should be getting Sprat, even if you're not a dedicated QRP guy. And I think our QRP credentials are on this podcast subject to question. People, we frequently go beyond 5 watts. I know. But the thing I always like about Sprat in the QRP world is their dedication to home brewing, that they are among the few people in the world that actually build radios and get on the air with homebrew gear. So definitely you should get Sprat, and you should try to get the summer edition. All right.
Hey Bill, one comment about that. I managed to get 5 minutes to look through it. Let me tell you what jumps out. The spare design. There's some really amazing projects in there that have such few parts, such commonly available parts. So if you're interested in home brewing, this is a really good place to start, because it's not like you're investing months and hundreds of dollars in parts. I mean, $30 worth of parts will build one of the projects. And George used to say, one and done. One evening's worth of work and you're done. And a lot of those projects are one and done. So, I mean, it's worthwhile if you want to get started. This is really a great place. It's not a lot on the technical side, looking and measuring IMD and all kinds of things like that. But what it does do is real simple projects that you can build and are successful. And there's enough information that you can replicate those.
I agree. I think that's one of the great strengths of GQRP and Sprat is the simplicity of the projects. Really great stuff. And I know, Pete, you over the years have put many articles into Sprat. I think that's where I first became aware of this guy named Giuliano out there on the West Coast. Was through the pages of Sprat. So in that sense, the podcast really has its roots in Sprat and the GQRP. So thanks to them. All right, Dean, the bench in Northern Virginia. Tell us about what you've been working on.
Well, Pete's comment about one and done just reminded me that I got to the point with the SBitX build. I have it all laid out on the plywood. I have it working reasonably well. And I was frustrated because I didn't want to do the work of building an enclosure and putting it in there. What do they call it? Socketry. I didn't want to do that stuff. And I started to lay it out, and I didn't want to do it. And I said, I need to find something else to do. I need to kind of set that aside, find something else to do. So I have a series of what I call 1-hour projects. So the first one was, I've needed for a long time an antenna switch, just a simple switch to allow me to switch the antenna between the upstairs operating position and the downstairs shack where I do all my work, because it's useful to have an antenna on the bench where you work. You got it all right in the same room. I've got it on 2 different floors. So I bought a little electrical junction box. I got one of these nice coax switches. I mounted it in there, put it on the wall where the antenna feed line comes in on the outside, and now I can operate from either the shack, upstairs shack. 1-hour project. I like that a lot. Second 1-hour project, power poles. I've got power pole connectors all over the place. I needed a expansion box for power poles so I could plug one in and expand it out to 4 different plugs. They sell these for outrageous amounts of money. I don't know why they're so expensive, but they sell them for a lot of money, and it's just a bunch of power pole connectors in parallel. Well, I found a 3D printable enclosure for power pole connectors. So again, well, it was an 8-hour print, but I didn't spend any time watching the printer, but put it together in an hour and one and done. Last one, another 3D printer project, Sanjian frequency counters. They're cheap, they're ubiquitous, but they're kind of flimsy. You got all the circuitry exposed. They just kind of flop around on the bench. Another little 3D printed enclosure with a battery connector. Done. Now I have a professional looking Sanjian frequency counter. So those are my 3 1-hour projects. And I just, there's a lot of satisfaction in building something, having it done, and saying that's finished. Because so much of what we do goes on and on and on and on. We're never quite finished with these homebrew.
Well, we're better than some people. We're better than some people.
This is true. This is true. We Bill and I have some colleagues in the club who take much longer to build projects.
Decades.
Like they never finish. But everybody has their own aspects of the hobby that they like. All right, so back to the SBitX. I just before departing for Oakland, I made my very first CW contact ever in life using the SBitX. I don't copy CW and I don't send CW, but the SBitX has it all in software. And Alan Wolke, W2AEW, had mentioned that he was doing some parks on the air activations, and I just put his call sign into DX Watch, DX Ham Alert rather, Ham Alert. And if you haven't used Ham Alert, if you're looking for a particular call sign, anywhere they come up on either digital or CW, they will pop up and send you an email. So I get an email, I get an alert on my phone that Alan was on the air, and I rushed down to the SBitX, fired it up, and I made a CW contact with W2AEW. So I'm very proud of that. That may be the only CW contact I ever make in my life, but
but one is enough if it's with Alan Wolke on the other end.
But it's with Alan. That's right.
My comment on this was the radio gods have spoken.
They have. So I've been doing some work on the SBitX software. Sorry, Bill. The software defined part of the radio. There's there's a crew of guys led by JJ W9JES that have kind of taken on the mantle of expanding and improving the SBitX software. Farhan's busy, and he's one guy working on it, and he's always thinking about the next radio. So just like on the MicroBitX, there's a group of people that have kind of taken on the mantle of maintaining and enhancing the software. And they've done a great job. They've moved it from the 32-bit operating system, which is obsolete, to the 64-bit, which is current. They've focused on the software-defined radio aspects of it. I asked them to add a notch filter. Next day, I had a notch filter, and that's tough to do with hardware-only radio. And SDR, it's couple of lines of code if you know what you're doing. I didn't know how to do it, but they did. The other thing I asked them to do, I got a custom fix in the SBitX software just for me, for all of the home brewers of the SBitX, which is me.
We have 100% of the population here with us today.
There might be one or two others that are working on it. As far as I know, I'm the only one that has a full up working rig. But my rig doesn't have a temperature compensated oscillator to control the SI5351. The commercial ones do. Mine does not. So my SI5351 is not right on frequency, so you have to have it calibrated. I got them to add a calibration constant so I don't have to recompile the code every time I get an update to the software. So those are my big contributions to the SBitX software world. On the other thing I decided to do finally, Bill, was put up an antenna inspired by your Hexbeam experience. And I'd get on the phone with Bill every morning and I'd hear about this new, contact with Asia or someplace I'd never heard of on the other side of the world.
Contacts, a lot of Indonesia over the pole.
And and I got my dipole up in the back. I can't even hear these stations. And he's like, oh yeah, I had 6 contacts with some far off place in the world. And so I'm like, all right, I got to get an antenna. And so just like Bill, following the example of a couple of guys in the club, I got the K4 KIO hex beam kit. I got the 6-band kit. It's nice. I mean, it comes with all the parts. It actually assembles in an hour or two. The first thing I do is paint all these fiberglass poles. That probably takes the longest of anything, but the assembly is actually pretty straightforward if you can follow IKEA instructions. It tuned up immediately on all the bands with low SWR. Very, very happy with it. I bought a Roan tripod, a 5-foot sturdy Roan tripod. It's going on the roof. Bought a Yaesu rotor. So the Roan tripod, I learned, uses American SAE standard bolts and screws. The Yaesu does not. It uses metric, right? So got a combination of all that stuff. And I always have the wrong wrench in hand when I'm trying to make an adjustment to these things. So it wants me to go back to the old adjustable monkey wrench. Of course, that's also called a nut rounder because that's what they do. So that's kind of been a lot of the project that I've been working on. Although I have done some radio work on the SPIT-X. The final amplifier stage was driving me crazy. You talked about the IRF 510s dropping off at high frequencies, Pete. Well, one of the things I learned from going through basically all of the literature I could find on these push-pull MOSFET amplifiers is that and this was kind of advice from Allison, which is that you got to pay particular attention to the input and output impedances and the interstage between all the stages. And I discovered that the reason my RD15s were dropping off at 10 meters, and there's no reason an RD15 should drop off at 10 meters. It's a VHF rated transistor, was that the output transformer, which was 2 stacks of 3 FT5043s side by side, it was dropping off at higher frequencies. And the fix was pretty simple. You put a 330 picofarad cap across the input to the output transformer, and adding that capacitive reactance to that part of the circuit cleans it up at the higher frequencies, and it didn't impact the lower frequencies. So in fact, I have more output now on 10 meters than I do on 20 meters, which is remarkable. So that was good learning for me. I hadn't thought about that, but it took a lot of cut and try and head scratching to come up with what turned out to be a very simple fix.
Once again, Allison comes to the rescue.
Yeah, well, Allison's very smart and she's very knowledgeable, but it takes me a long time to understand what she's advising. Sometimes I read it, I'm like, I don't get it, and I have to come back to it like 3 or 4 times later. But that's because I don't have the electrical engineering training, and I don't necessarily have the vocabulary. So you struggle at it a little bit. So the other one is, if you recall last time we talked about what's the term for a transistor that conducts when it's not supposed to, Pete?
Subthreshold conduction.
Subthreshold conduction.
I have nightmares about subthreshold conduction. I wake up with a cold sweat.
So I had fixed one problem with the SPIT-X transmit stage, which was the TXRX relay was turning on when it wasn't supposed to. And I fixed that at Pete's suggestion by putting in some caps to ground, and I eventually replaced the transistor with a different transistor, and it fixed it. But it didn't fix it. It didn't fix another problem that I was having, which was I was noticing that sometimes I would have low output on some of the bands, and sometimes I wouldn't, at the same power level and at the same frequencies, and it was driving me crazy. And in thinking about it, the only thing that could have been happening at this point was something in the low pass filter board, because I've got 4 filters that are in parallel, they're relay switched. And I had this thought that maybe more than one relay was coming on. It's hard to hear because they click at the same time. So I put an LED across each of the four relays. And sure enough, I'd go into transmit. The one relay that was supposed to come on would glow really bright, and the other three would flicker like Christmas lights flickering. I'm like, okay.
Now, not a good thing.
It's like, all right, I'm supposed to have one of these things on. And so I went through a whole series of trials and tribulations, which I looked last night. I made 4 videos on this that I have yet to post. I will post them whether anybody looks or not. I will post them on the blog for my own historical knowledge, so that I know to go back to them. But the fix there turned to be pretty much as simple as a cap from source to ground in the relay circuits, and I did switch the NPN transistors out for FETs, and the combination of those things. No more LPF leaks. One LPF string comes on at a time, and that was actually very satisfying. It just took days to do. What, again, you find out, it's always easy once you know what you're doing, right? At the end. So last thing is, Bill, you and I have been doing a lot of work on third order, intercept, intermodulation, distortion, looking at the quality of the signal output of our amplifiers. And what we find is the waters are deep and they're kind of muddy.
Yeah, this is the thing. I was telling Dean about it. I started out with phone with double sideband, and I was just happy if I could see the SWR meter wiggle when I spoke into the microphone. Woohoo! That was great. I was modulating. I didn't really worry about it beyond that. Then I got rid of one sideband and I started doing single sideband. But again, if I was modulating, it looked okay. I would sometimes put it on the oscilloscope and see if my waveform was correct. Right? You'd put a 2-tone test in there for a single sideband and see if it was correctly shaped. But it was always hard to tell when you're looking at to see if it's curved right. It is hard to tell whether it's rounded or whether it's starting to flat top. And this could make, as we found out, a big difference. And then we all got these things, the Tiny SA, and then even beyond the Tiny SA, the Tiny SA Ultra, which has an RBW of 200 hertz, which allows us to see the spikes. But go ahead, Dean, tell us what happened.
Well, so first off, a 2-tone test is a good way to look at intermodulation distortion. But virtually every reference you read just says, put in 2 tones that are not harmonically related and look at the third order product. So on the spectrum display, when you get all through your amplifier chain, you'll see 2 big peaks, which are the left and right tones. And then just to the right and the left of those, you'll see the intermodulation, third order intermodulation products, which is take signal A and signal B and add them together, A plus B minus A, and A plus B minus B. And those are the 2 third order intermodulation products. And you want those to be 30 dB or more down, but at what power level? And nobody tells you what power level. And as you change the bias, things go up and down and you're not really clear. So you can actually produce a test that looks really good and still have an amplifier that's not working well. And you can produce a test that looks terrible and have an amplifier that's actually working just fine because you haven't set up the test parameters right. So big shout out to Helga Greenberg, Motorola Engineering Bulletin 38, EB38, intermodulation distortion of linear amplifiers. Great paper on how to properly set up an intermodulation test and how to interpret the results. Key issue is you want to be 6 dB down from the 1 dB compression point. The 1 dB compression point is the point at which, as you're increasing the drive, the output no longer becomes linear. As soon as you hit that, then you got to back off 6 dBs from that. Then you can do the test. But the test doesn't tell you about anything other than how to compare your rig with other rigs that are tested with a similar feature. That's all it really tells you is what is the third order intercept and the third order modulation products of your rig when subjected to this particular test. Because Bill asked the question, well, 30 dB down, well, how about the FCC requirement that says that spurious emissions have to be much lower than that? Well, I think the answer is that the two-tone test is an artificial test that's really meant to compare amplifier performance one or the other. It really isn't measuring how much spurious emissions are coming out of your transmitter. Because if you think about it, when we're talking, we're never producing two tones that are exactly harmonically not harmonically related, that are at exactly that point and that are sustained like a continuous key down. That just doesn't happen on a SSB or phone transmitter. So that's kind of my conclusion. But a lot of testing and conclusion that I think the amps that we're building are pretty clean. We use pretty good techniques and they seem to work pretty well, as long as you pay attention to where you have the bias. Because if you bias it closer to Class A, you're going to have lower products, lower intermodulation products, but you're going to waste more heat and energy, need bigger heat sinks, all of that.
Yeah, what got me thinking about this was when I started Googling on this topic, it immediately took you to a lot of the ARRL QST pages about this. And the pages were mostly focused on SDR rigs. And the whole idea was we've got to clean up the signal quality of these rigs. And it was really for me, kind of scary as a home brewer, because the assumption seemed to be that, this is not something that can be done by actual radio amateurs. The focus has to be on the manufacturers to make sure the manufacturers of commercial SDR equipment build their commercial SDR equipment in a way that doesn't produce splattering signals, right? So it was very commercially Kenwood, Yaesu, ICOM focused. And I just started thinking, well, wait a second, if they start imposing these kind of standards on all of ham radio, we as home brewers could easily be caught up in it. And I really was kind of concerned about that. I looked at Bob Sherwood's page, and he has some good articles. Sherwood has some good articles on how the time has come to clean up our transmitters. His focus has always been on receivers, but he took a look at transmitters, and he concluded that by far the cleanest transmitter that he ever owned was the Collins 32S3. And he actually showed the spectrum analysis printout from the Collins 32S3 as compared to a typical SDR modern transceiver. And even from looking at it, it was pretty clear that the 32S3 was doing a lot better than the standard commercial transceiver. So
I guess the other thing about the third order intermod test is you're really only looking at a very small slice of the transmitted spectrum, because you're really only, for that test, you're really only looking at those third order intermodulation products, right? And it's not really telling you if you've got spurious signal that are outside of the little window you're looking at. So sometimes it's useful to just set your spectrum analyzer to a wide spectrum display and transmit and look what's happening across the entire RF spectrum.
I think what the thinking there is that the third order product will be significantly higher in strength than all of the other products. So that if you get the third order product down to a sufficient level, even though the other ones might still be there, they're going to be at 40 or 50 or 60 dB down, and you're not going to hear them. The other thing that I found out when I was looking at this, you were looking at some really good points in terms of how to set up the test. But what you realize is a lot of the way that a signal is perceived, especially by somebody who has a waterfall, will be based on the strength of the signal that is receiving. So in other words, if the signal is coming in at 40 dB over S9 and your third order product is 40 dB down from the peak, that third order product is going to be at, guess what, S9. You're going to be hearing the third order product. It's going to appear to be splattering, and it's going to appear to be splattering not necessarily because it's a dirty signal, but because you're receiving it so strong. You're receiving a 40 dB over S9 signal. And you notice it when in some of the articles when people talk about a lot of it will also depend on the signal to noise ratio, how much noise you have at your end. If your noise level is 30 dB down at at a certain level, and the products, the IMD products that you're putting out are below the noise, the other station's not even going to hear them, and he's not even going to be able to detect splatter. So a lot will depend on the strength of the signal, and not necessarily you could have a signal that sounds splatter, like it has a lot of splatter on it, but you always hear these guys on 40 say, my God, man, you're 40 dB over S9 and you're broad as a barn door. Well, maybe you're broad as a barn door because you're getting him at 40 dB over S9. I don't know, Pete, what do you think?
Yeah, I think there's a lot of truth to that, Bill. And one thing that's useful about SDR is you can see that signal and see if it's wide. Now, I've been observing some signals that are 40 dB over S9, and the spectrum is like this.
That's right. That's a
And
good
then
point.
some 40 over 9, the spectrum is like this.
Yeah,
So that I can distinguish when someone is splattering versus a strong signal.
that's
So I
right.
mean, when you were talking about that, I looked. I said that's a 40 dB over S9 signal, and its bandwidth is the brick wall filter.
Right.
But some of those are extra wide. So I think a lot of that is guys just crank it up and don't care.
Yeah. Turn it to 11. Yeah.
Yeah.
11's better.
Also, I think a lot depends on the quality of the receiver that the person's using. I noticed that some of the web SDRs, and they're a great resource, but if you look at what they're using as receivers, they're using the dongles. Wait a sec. I even got it. Let me show you. This is my latest dongle receiver that I got. This is the complete receiver right there, right? And
Cool.
it works great, but I wouldn't trust it in evaluating somebody's SDR performance, because it looks to me like it could easily be overloaded, or I don't know. I mean, a lot of the problems could be in a receiver this tiny, this simple.
Broadband. Broadband.
It's very, very broadband. But anyway, the IMD example it's been really useful, and it's caused me to go back and use the Tiny SA Ultra spectrum analyzer to sort of take a new look at, okay, how clean is this signal? I mean, going back to a CW, then double sideband, single sideband. Now we're fretting over IMD because we have the tools to take a look at the signals.
Bill, you got your $150 spectrum analyzer, and we've joked about wanting to get better spectrum analyzers. And, I have my mouth waters when I see Alan Wolke with his high-end professional Tektronix gear. And so I put in an eBay search for some of this stuff. Now, eBay has decided that I am interested in $20,000 spectrum analyzers. I price lowered to $19,950.
Go for it, Dean. But I would just say, buy it through the Solder Smoke blog, because we'll get 5% from Bezos.
Yeah, there you go.
Get $4 or $5 grand there, man. It'd be good.
I think if I told that to Sandy, I might be living alone.
Well, the thing about it is, if you get a spectrum analyzer that expensive, you become so nervous about it, because if you put a little bit too much RF in there,
yeah,
the thing goes poof. I have blown up one of these things already, right?
yeah.
Guess what?
Next day.
Get another one on the front steps, So
Was it delivered by one of Bezos's drones yet?
No, not yet, but I think that's coming. Hey, enough of IMD. Two other letters that have reared their ugly heads, Dean. AI. So Dean and I have been talking about AI quite a bit, and I am not a software guy, so I often get it wrong on AI, and I have to go to Dean, and Dean brings me back to earth, and I stop fretting about AI. But I noticed just last month that there's this that Google has put out this product called Notebook LM. And the thing that caught my eye about Notebook LM is that there's a website, and you just go to the website. You could put the URL of anything in there and put it in there. So I put the URL of the Solder Smoke blog, just the URL of the blog. And I said, make me a deep dive podcast. So I did this, and I was telling Dean and Pete, it took me all of about 5 clicks just to move the URL in there, copy, click, paste, boom. Then make the podcast as another click. And okay, so maybe 4 or 5 clicks. For me, all of about 1 minute's work. The machine churns a little bit. It took about 3 minutes, and it produced the podcast, a deep dive into solder smoke. I did it first with the blog, then I did it with the actual podcast. And I must say the product, while not perfect, was pretty darn good. It was pretty impressive.
Bill, it was only 2 years ago that we predicted Pete GPT on April 1st. Right?
I know, that was it. That was a joke. That was our joke, that we were going to use GPT to substitute for Pete whenever technical problems or other responsibilities kept him away. And here they were doing it. I mean, the responses we got from the community were kind of interesting. About half of the responses were like us, grumpy old guys saying, well, I don't like the girl sounds fake, and I prefer Pete and Bill and Dean. Okay. The other half where people were saying, and I think this is the real point of it, that this is really kind of amazing, almost scary, amazing technology. Because these people do not exist. There is no guy and a girl who sit there and talk and joke and banter and go back and forth and get most of the points about the Solder Smoke podcast and blog. They get it right. Pete, you're nodding. I know. What do you think, Pete?
Oh yeah, I ran a test. I took one of my YouTube videos, and they talked about it, and I'd say it's probably about 95% correct.
Yeah. I mean, and what I said to Dean and I were talking about this. I said, if you took the podcast and gave it to actual human presenters who didn't know a lot about it, the number of errors they made would be comparable or greater than you get from the AI.
I think though that they have turned the enthusiasm dial literally to 11, because these are very enthusiastic podcasts. I put one of my blogs in there. Man, I felt like a superstar after they talked about me for 10 minutes. Like, woohoo!
Well, I don't know this for a fact, but I was telling our buddy Grayson, I said that, I think that many of our listeners, when they listen to the podcast, when they start hearing especially the young lady talking about how great Solder Smoke is, that they'll be trying to get her phone number.
Yeah. Well.
I mean, there was actually a picture that came up of like the robot and the humanized version of the robot. Should be getting some calls.
Yeah. There you go.
But anyway, I have links about about how the AI podcast came about, and then I have links to the 2 Solder Smoke podcasts that we actually produced. I have them up on the show notes, I guess you could say, and you'll see them. And if you want to listen, just listen. Let us know what you think about this. I mean, look, it's not perfect. If you listen carefully, you could probably detect that it's AI. But realize this whole system was produced 2 weeks before I made these recordings. This is all happening in the last month or so.
Yeah. So Bill, let me add a little bit of commentary here. So you guys know, but maybe the listeners don't know, I have a long history in this field professionally, and I actually know a little bit about it. And the thing that we all need to be aware of is that this fake media generation is getting better and better and better, and we're on a curve to the point where it'll be very difficult for us to distinguish truth from fiction, and particularly in the media that comes streaming across the web, because it's easy to produce. We didn't produce Pete GPT, but guess what? You can actually do it now. We can train a we can train an AI model on Pete's voice and have it pretty accurately produce Pete's style of speech and voice. So
Pete is going to come out in favor of LCVFOs.
there you go.
Enough of this SI 50.
We will do that. All I would say to everybody listening, to the 200 people that are going to click on this, is just be wary of the media that you consume. And right now there are tells. Like if you listen to these guys, if you listen to more than one of these podcasts, you kind of get, all right, I get what this is, and it gets old fairly quickly because it's the same banter, it's the same kind of there's an oddity in AI generated human characterizations that always sounds just a little bit off, right? And you can usually detect it. Usually it's just this uncomfortable feeling that you get when you're looking at this thing, but that's going to go away soon. And so we got to be cautious. I think the media companies have an obligation to start watermarking their media, so at least we know where it comes from. So that's it. Political, educational content over. Tune in next week for more AI with Dean.
Dean and Pete. How do we know that you're real right now, Dean? We don't know.
We don't know.
Could be.
I could be a simulation.
Could be. We all could be simulations. Who knows? All right. Let's see. Pete, your time at the bench is extremely limited, but we're grateful that you have done some projects. So tell us about the PNP rig.
First up, behind me is the Nittany Lion, Penn State. Moved up to number three.
All right, there you go. We have sports talk here. Sports.
Number 3, Nittany Lion. There you go.
I was going to ask about the Lions. I'm glad you got to explain that.
Yeah,
okay,
Nittany
good.
Lion. Yeah, Penn State, number 3. Well, I have just a couple of things, but Bill, I want to go back to your earlier comment about the Empire State Building being built in 1 year. I was totally amazed by some things I happen to have knowledge of that occurred during the 1930s. And specifically, the year 1938, 1939. I'm aware of 2 major construction projects that took place to support our defense efforts in the late 30s. In 1939, the winds of war were in Europe, and people sort of thought we were going to get involved. They built an aircraft plant in Tulsa, Oklahoma, that the building is 1 mile long, it's 300 feet wide, and it's got a 30-foot clear span. So it's 1 mile long, 300 foot wide, 30 foot high. And this was built by Chicago Bridge and Iron, Tulsa, Oklahoma. And it was an aircraft plant. And at the height of the war, every 20 minutes, an airplane was coming off the line. But in 1939, this was an advanced approach to manufacturing that they had. As the aircrafts moved down this 1 mile line, they had all the sub shops along there. So as you were building the airplane, what you needed to put on that airplane was right there in the line. That's why it was 1 mile long. But if you look at the inside of the building, it looks like a bridge. I mean, all the bridge work, all the structure, there was 300 foot wide, no posts. I mean, there was nothing to impede the production line. 30 foot high, so you can get the airplanes, one every 20 minutes. So that was built in 1939. They built another one in Texas. It's at now Carswell Air Force Base. And of course, they made the building 20 foot longer because it was Texas. So instead of being 1 mile, it's 1 mile and 20 feet. But there's 2 identical buildings. I've been to both of them. Another thing they did is in St. Louis, where I spent a little time, the McDonnell Douglas plant. Originally, it was a Curtiss Wright plant. In 1939, the winds of war, they built the building, but they had the original Curtiss Wright building inside of the building. So they built the new building totally around the Curtiss Wright building. And when they were done with the outside, they dismantled the inside. So they never stopped production. So, I mean, they were building. 1930s, they didn't have lasers, didn't have computers, didn't have all these things. And as a matter of fact, in the Tulsa, Oklahoma plant, they had to build a rail line to bring all the materials out. So, I mean, this thing was out in the middle of nowhere. They had to build a railroad line. And in 1 year, they built that plant 1 mile long, 300-foot wide, 30-foot clear space to the ceiling. Every 20 minutes, a plane came off that line. So, I mean, it was amazing what they were doing. And it was, like you say, the Empire State Building built in a year. How did those guys do it?
Well,
How did they do it? They didn't have computers, they didn't have lasers, and the construction equipment was not as sophisticated as we have today. So it's amazing how they were able to do that.
Just
You know, I
like the
understand.
pyramids, it was aliens.
Yeah. Oh, okay. There you go.
Well, related to that is I understand today that people who are in the construction business, especially the building or bridge or civil construction business, hate it when somebody says the words Empire State Building, because whatever they're doing, it's not going to be done as quickly as it was done in 1930, 1931, which
And it's
is
probably gonna last 100 years either.
I drove past that building. The building is 100 years old.
Yeah.
People they're still operating out of the building. It's almost 100 years old, and they built it in a year. It's
Well, there were
amazing.
some really smart people running this country at that time, and I'm not sure we have that level of sophistication today. When I went out to Midway Island was a clipper station, Pan Am clipper station, and at most they maybe had 600 people there in about 1935, and they had sort of temporary buildings, and they decided to go from diesel generators to a real power plant. And I happened to go out to Midway because they were looking for an officer that had an electrical engineering background because they were having problems with the power plant. So I looked at the construction prints for this power plant built in 1935 on Midway Island for 600 people. And the capacity of that generating station was 10,000 people. So I'm trying to say, why would you build a plant that can support 10,000 people when you only have 600 there? Wins the war. They realized something was coming, so they said, what's the most critical thing that we have facing us? Electrical power. So they built a power plant to support 10,000 people. I mean, who were the smart people that figured this all out at that time? I mean, there were some guys in our government that realized that things were going to happen. They just did some things that we didn't know about, but then later on were very significant as we got into the war effort. Okay, let's talk about radios. I have only two small subjects I want to talk about. And one is on the blog, which I'm no longer blogging, but the information is still there, is I decided, why can't we build a PNP transceiver? Instead of using NPN devices, PNP devices. And so I essentially took the P3ST design, which is 7 transistors, and I converted everything to PNP. Now, first off, there's a body of knowledge that says why you would use NPN versus PNP. And a lot of this has to do with the performance level at the extreme. So the PNPs are not quite as good as the NPNs if you're looking performance levels. And I think, Bill, you uncovered a paper from Sony where they analyzed and says, what would you use, NPN or PNP? And they concluded for what they were trying to do in the audio products area, NPN were better than PNP. But that doesn't say you can't use PNP devices to build a transceiver. So essentially, I presented some LT Spice simulations that show how to use the PNP devices in every spot. And I even found a P-type IRF 510 that simulated okay that you could do. So there's an opportunity. You can look that information up on my blog. If you have a big old jar of PNP transistors, you may be able to build a transceiver on it, just because, not any specific performance improvement, but I always wondered, why is everything NPN and not PNP? So you look in the blog, it can be done, the simulations exist, and I actually have built some of the specific subcircuits, like a microphone amplifier works very, very well. As a matter of fact, guys who build the fuzzbusters for the guitars like the PNP, germanium PNP. They just have a real quality to them. So PNP germanium transistors are very expensive today, especially the old ones that they build into these fuzz boxes.
I have the link. I have the link to your article up on the show notes, Pete, on the 20-meter SSB transceiver using PNPs.
Yeah.
You know, we all buy these boxes of cheap transistors from Amazon. Half of them are PNPs, and if I look at the bins, all my NPNs are used and all my PNPs are full.
Yeah,
So
there you go. I have the two devices that seem to work really well are the 2N2905, and you'll see the 2N2905 are used frequently in CW transmitters as a means of a DC switch to provide power. And the other one is the 2N2907, which is like a 2N2222, and the 2N2905 is like a 2N2219. So if you got some around, it might be a fun thing to do. So that's one of the things I was doing. I didn't actually get a chance to build a whole transceiver. I have built some of the sub-circuits, but the simulations exist for all the major components. You can see the LT Spice. The other thing is not having the time to really build stuff anymore. I've been cycling through some of the old radios, boat anchors I have, and you put them on the bench and you look at them and you say, man, we paid a lot of money for not a lot of capability. I have some national and Helicrafter units that the national lower price ones have a nonlinear VFO. I do not understand why that is the case, but you get at one end of the band, you got a lot of tick marks, and you go to the other end of the band, you got the wide open spaces, and say, why couldn't they make a linear VFO? Now, Galaxy figured out how to do it, and some of the other companies.
So did Drake. So did Drake, and so did
Drake. Yeah, you
and
just
the Helicrafter transmitters too.
Yeah, you just wonder why they didn't do that. But I mean, these things cost a lot of money. Like for instance, one that does have a linear readout national is the NCX5, but it's a mechanical digital dial. This is shades of the HRO, and I think Jimmy Millen had his hand on that. So it's the old mechanical digital clock. You know, you see the numbers turn over, but they're mechanical and not an LCD or LED display. And they actually work pretty good. But one of the things that's interesting is the AGC circuits in those are pretty rudimentary. A couple of diodes, a cap, and a resistor. I mean, there's nothing very sophisticated about the AGC, and often it's off the end of the audio-derived AGC. So you get this pumping action. So it's got AGC, but you say you got to crank the RF gain control back in order to get something that's consistent. And yet we enjoy really sophisticated AGC circuits. And some of those radios back in the early 60s were like $600-700. Read about $5,000 for that in today's dollars. I mean, people are paying a lot of money for something that you could homebrew today that would, beat the pants off that. So there's a lot to be said for the old technology and what we paid for. And someday in the future, people look at the IC 7300 and say, man, that's like doing burn surgery with a rusty spoon because the technology moves along. But it's interesting to see that these radios still can work today. Most of them are vacuum tubes. Some, like the NCX5, has a solid state VFO in it, but a 2N706. Well, we pick a different device today, but in 1960, the 2N706 was quite the transistor. So it's a lot of fun to play with those radios, but after about an hour or so, my ears hurt, and I'm saying, man, someone needs to fix that AGC circuit in there, but that's what we live with.
On the transmit side, I keep thinking about Sherwood's comments on the Collins 32S3. And one of the things that when you see the discussions of this like clear signal stuff, they are, I think, correctly kind of down on transistor RF power amplifiers, especially the LDMOS. But then they make this statement like, well, obviously we're never going back to the 6146s. And
Why thinking,
not? That's what I'm thinking. I find myself pulling out a chassis, thinking about then I think, wait a second. I do not want to blow myself up in search of greater IMD performance. I can live with that higher order, third order spike than, but I mean, if you wanted to, a 6146 running Class A with some feedback, you wouldn't see any spikes.
Yeah, right.
Well, Grayson's building his Thermatron Mighty Mite.
I know.
You gonna build one of those, Bill?
Maybe well, I'm thinking about, instead of the EB63A, man, just going full 6146s.
Sure.
I'll send flowers.
But there's something else about that Collins design, Bill. It's not just the 6146s. It's what's ahead of that. You look at, there's specifically a mixer circuit that they have in there when they do the signal mixing. It's a balanced mixer. So I mean, they're doing things that like the old garbage in, garbage out, but they've already addressed that problem as a whole system. So it's not just the final amplifier that was pretty well designed, but it's everything ahead of that.
Yeah.
So I think it's much to be said for the Collins design. I mean, you pop the hood, there's a lot of tubes in there. I mean, you can get away with 5 or 6 tubes, but they got 13 or 14 in there, and there's a reason for all those tubes.
This is an interesting point, Pete, and there's a very unscientific approach that I took. But when I was thinking about or fretting about IMD coming out of the homebrew transceivers, I started thinking, well, wait a second, where is this IMD being produced? Most of the focus, when you read about this stuff, the focus is on the power amplifier. But is a lot of the IMD being produced ahead, going into the first driver? So I put the Tiny SA and I took a look, and I put the two-tone test in. And although at this power level and at this input level, I was seeing fairly high IMD third order products coming out of the power amplifier, when I moved and I went back, and even when I terminated it properly, because Dean pointed out that I needed to terminate it properly, when I did, the IMD coming out of all the circuitry prior to the power amplifier stages was really almost undetectable. The real problem with IMD started cropping up when you started going into power amplifiers that were far from Class A. They were at best Class AB. And that's where you started really seeing the IMD products. So I think that there might be a point in focusing on the power amplifiers. And one of the things that Collins,
if you overdrive the driver stage, though, if you
or
overdrive the driver stage,
the
same thing is going to happen. And you can fuss all you want with the power amplifier, but if you're overdriving the driver stage,
that's
you're
right.
not going to fix it.
Yeah, right.
The whole system.
That's right. But like on the BitX transceivers, one of the things that Farhan did when he designed it, and I think this carried over into the TIA amps, were that none of the amps were operating close to the point where they were going to either saturate or distort in some other way. They were all operating kind of far down on the curve. So that would really suggest that, yeah, you really do have to watch those driver stages in the PAs if you want to make sure that your signal is clean. But Pete, I really enjoyed your look at the old boat anchors. I remember I saw the video with the KWM1 on there, looking good. Hey, guys, we're at 1 hour 24 minutes. We've been talking a lot. I'm going to do the mailbag. Let's do the mailbag real quick because we've been accumulating a lot of mail here. Lex PH2LB is making some new stickers. Look out, San Francisco. Arrest warrants may be issued. Roger PA1 Zulu has sent a lot of good ideas and links. And one of the things that Elisa always does is Elisa always consults with Roger about what she should get for me for my birthday. And this year, Roger suggested Practical Electronics for Inventors, which has arrived. Thank you, Roger. It looks like a really good book. A lot of good ideas in there. I may become an inventor. Todd K7TFC, he had some great ideas about what might be behind the decline in Solder Smoke podcast and blog listenership and readership. Really good ideas. Thank you, Todd. Another Todd, VE7BPO, also known as Vasily Spasibo Vasily. He sent some great information on how to stabilize an LC oscillator. Pete, I know you were really interested in this. Yeah. A lot of good info that Todd passed along. Eric 4Z1UG, Dean mentioned him, and he did provide some welcome words of encouragement on the blog of the podcast. A lot of it was, as Dean indicated, frankly, too much work, but I think he has a different approach to his podcast, QSO Today, so he was willing to do that. Dave W2DAB, who I mentioned, is on the Upper East Side in New York. I didn't get to see him on this trip. but he was one of the ones who commented on the AI podcast. He said that the AI podcast just can't replace the Tappet brothers of ham radio. And I said, wait a second, we're now the Tappet triplets. The Tappet triplets. Thank you, Dean. We heard from Michael, AA1TJ, the wizard of the Hobbit hole up there in Vermont. And he was thoughtfully skeptical about the AI. Thank you for that, Michael. Grayson, we talked about Grayson, KJ7UM. He commented on the signal cleanliness of the 32S3. Grayson did an amazing video on the Thermatron Michigan Mighty Mite, which Dean has pointed out, and that's on the blog. That's on the blog also. Mike WN2A, who we hear about a lot, who's been in the game for a long time. He's now working on DC receivers and hum, direct conversion receivers and hum. And I told Mike, I said, we didn't have any hum problems with the little DC receiver that we made with the students. I don't ever remember us having hum trouble there. Florian OE7 FTI is building Farhan's JBot amplifier. There's a blast from the past. JBot, just a bunch of transistors. This was something that Farhan came out with years ago. And I built a bunch of them, put them in different rigs at different times. Mike Murphy, WU2D, who's a real star on YouTube right now. He's building a 1930s replica rig using a Frank Jones circuit. Good. Frank Jones, man. The circuitry looks good. I really like Mike's videos. He's got a great YouTube channel. Check it out. Dave, K8WPE. It's always great to hear from a good, strong solder smoke supporter. You know, Dave told me, he said that he had not yet recently been catching up with the blog. And I wrote to Pete, I said, Pete, if we're losing Dave, we're in a lot of trouble.
Yes.
But thank you, Dave. Another very loyal reader and listener is Walter, KK4DAS, the Wizard of Orlando.
Oh, I'm KK4DAS.
I'm sorry. I got the call sign wrong. But Walter, KA4KXX.
There you go.
Oh, there you go. He's the Wizard of Orlando. And Walter always provides some really great info. Paul G0OER was reacting to that video that I put up about ham radio in Southern California in the 1970s. Who knew that we were so cool? Girls were interested in us because of our ham radio licenses. I don't remember any of this. Do you guys remember this? No. It must be some video magic, but
so unlike you, Bill, when I was 13, my dad was a ham and he tried like hell to get me involved. I'm like, I'm staying as far away as I can, and I did until I was 50.
But here you are now, Dean.
But here I am now.
I didn't remember. And Paul over there in England, G0OER, apparently the lack of coolness applied in the United Kingdom also. Thomas K4WSWL is down there in Asheville, North Carolina, and struggling with the results of the hurricane. Hang in there, old man. Nick M0NTZ is building yet another direct conversion receiver with lots of videos about it. He did one recently on the audio amplifiers. Here's a guy out in Texas that we hear from. He keeps us posted on his projects, and it's really, really good. Michael AG5VG. And he is building a Mythbuster style 20-meter rig using the FT101 VFO. Fine business. We just heard from Michael. Michael was fooling around with the issue of whether the screws going into the PTO should be brass or steel. And you know, this actually demonstrated for me one of the uses of the blog, because I was able to go back to the Solder Smoke blog, find the article that I wrote. I only remembered half of it. But there it was, all the details about the differences between using a steel screw or a brass screw. And I was able to send that to Mike.
This is another reason to keep the blog up on the internet, Pete, because
tribal
for
knowledge.
you can go back and find your own stuff. That's because that's the problem I have. I write stuff. I recorded all these videos as I'm building things. Some of them I've never posted. So last night, for example, I realized I had 4 videos on the LPF leak that I haven't posted yet, and I had to go find them.
Well, this is one of the problems with a really lengthy blog. I mean, there are over 1,000 articles on the Solder Smoke blog, over 1,000, right? There's probably 5,000 links on the blog. I get this message from Google saying, We've detected that some of the links on some of your articles might lead to phishing attacks on some of your readers. So please correct them. Well, which ones? Where which of you think I'm going to go through and check 5,000 URLs? Thank you, Google. Thank you. Let's see. We heard from Tony G4WIF. He gave some good advice on the listenership problem that we've been discussing. And then John AB2XT, he sent the three of us a total of 6,047 picofarad NP0 capacitors. I think it's safe. Dean got 2,000. I got 2,000. Pete got 2,000. I think we're good for caps. Thanks, John.
You know that 47 picofarad is needed as the coupling capacitor of the middle inductor on the W3NQ filter.
There's gonna be a huge spike in W3NQN low pass filters.
That's what you need for 20 meters. The 40 meters is 100. If you only have the 100s, we can do the 40 or the two 47s will get you close.
Pete, you could go into the low pass filter business now.
Yeah.
And finally, we heard from our good friend down there in Melbourne, Australia, Paul, VK3HN. Paul was suitably impressed by the AI podcast. He just said it was amazing. Thanks for noting the amazingness, the scary amazingness of it, Paul. Hey guys, we've been going on now for 1 hour and 32 minutes. I thank you both. Pete, thanks for getting up early in the morning.
By the way, I've named them. It's Fred and Ethel, and that was based on an input from Todd. So we have the Fred and Ethel banter.
I don't know. I think Ethel. I think she needs I think she's more of a Roxanne, if you know what I'm saying. Maybe Fred and Roxanne.
Yeah,
hey, but this is a family show, so we're going to end it there.
Yes.
7-3s from Northern Virginia, from Falls Church, and Dean is also in Northern Virginia.
7-3 from Great Falls.
7-3s from a dark left coast. The sun is not up yet.
7-3s, guys. Thanks a lot.